Hello students, welcome back to my YouTube channel. In this video, I am going to discuss about circular current loop as a magnetic dipole. Current carrying circular loop will produce magnetic field. The direction of the magnetic field can be found out by using right hand rule. How will you apply the right hand rule? Curl your palm in the direction of current, then the thumb point the magnetic field direction. Here it is, thumb is coming out. This is the magnetic field direction. Another circular loop, if the current is going like this, if you apply the palm rule, you can get the magnetic field is going into it. Okay? So, I have compared this direction with the magnet produced magnetic field direction. And consider a magnet. This is a magnet, north and south. From the north pole, magnetic field line is coming out and end at the south pole. You look at here, the magnetic field line is originate from a pole, that pole is north pole, and the magnetic field is end at a pole, that pole is south pole. So this I can change like this, that is, if the current is going like this, here you see that the magnetic field line is coming out from this loop, that is, this side is act like a north pole, like this. Okay, and for this loop I will apply the right hand rule. I will get the direction of the magnetic field is going into it. That means the field line is entering. Field line is entering, that is act like a south pole. So this is act like a south pole. Okay, clear? This is act like a south pole. Okay, based on this, we will find out the direction of the magnetic field due to a circular coil in the two sides. Okay, so I am consider a circular loop. This is a circular loop. The current is to be going like this. Okay, so like this. So listen here, this is the circular loop. Okay, in the circular loop the current is going like this. I am going to find out the direction of magnetic field. How will you find out the direction of magnetic field? Curl your palm in the direction of current. So I will get the thumb direction is upwards. So from this the magnetic field line is originating. So this act like a north pole. Okay, this act like a north. Okay, then, and so the top side of the circular loop is act like a north pole. Now I am going to find out the direction of the magnetic field in the bottom side of the circular loop, in the bottom side. So the current is going like this. You see, the current is going like this. So I will apply my palm. I curl my palm in the direction. So thumb is entering into it. So here we can see that in the bottom side of the circular loop, the field line is entering. So here you see, this is south pole. Why it is act like a south pole? Here you look at where the field line is enter into it, there is act like a south pole. So look at here. In this circular loop, the top side is act like a north pole and the bottom side is act like a south pole. So this is similar to here. This is a magnetic dipole. Two poles separated by a small distance. Here also you see that two poles is separated by a very small distance. So we can say that current carrying circular loop act like a magnetic dipole. Okay, current carrying circular loop is act like a magnetic dipole, or we can say that circulating current produces magnetic dipole. So in the current carrying circular loop, the current is circulating. So we can say that circulating current produces magnetic dipole. Okay, clear? So now we will see what is the behavior of the magnetic field produced by this dipole. Okay, behavior. So I am consider circular loop like this. Okay, if the circular loop is to be like this, here the current is going like this. The current is going like this. What about this side are like a south pole, and this like a north pole, and this side is are like a south pole. Okay, clear? This behavior of the magnetic field, we have to find it. So first of all, I am assuming that this is the center of the circular loop. The current is to be I, and R is the radius. There is a point P is along the axis. P is along the axis, which is at a distance x from the center of the circular loop. What about the magnetic field along the axial line? The magnetic field along the axial line is mu 0 I by 2 r square divided by r square plus x square all power 3 by 2. If the x is very larger than r, what about r square plus x square? X is very larger, x square is again very larger. Add with a small value, that is nearly equal to what? X square. So now you can change this equation, that is B is equal to mu 0 I by 2 r square divided by x square all power 3 by 2. That means B is equal to mu 0 I by 2 r square divided by x cube. Okay, this is the magnetic field at a point along the axial line of a dipole. Okay, this equation I will make some changes. Okay, I will multiply with this with the 2 pi. I will multiply in the both sides. So what I will get? B is equal to mu 0 I by 2 into r square divided by x cube multiplied by 2 pi here and here. Okay, now what you will get? Mu 0 I by 2 into pi r square divided by this 2 pi multiplied with this, so you will get here 4 pi divided by x cube. So what is this pi r square? Pi r square you will consider as that is the area of this circular loop. So B is equal to mu 0 divided by 4 pi 2 into I into A divided by x cube, and B is equal to mu 0 divided by 4 pi 2 into IA. What is IA? IA is the magnetic dipole moment. Previously we studied that the circular current loop act as a magnetic dipole, we call it as. That means this side is act like a north pole and this side is act like a south pole. Okay, this. Okay, so the strength of the magnetic dipole is expressed by a term that is magnetic moment. Magnetic moment. Magnetic moment M is equal to NIA. Okay, where N is the number of turn, A is the current through the coil, and I is the current through the coil, A is the area of cross section. Okay, so if N is equal to 1, What about M? M is equal to IA. Clear? M is equal to IA, where M is the magnetic moment, that is the strength of the dipole. Okay? So this direction of M is similar to the direction of area of cross section. Okay? Area of cross section. Okay? The area of cross section direction we can find out by palm rule. Okay? Clear? Then this value we will apply there. So IA is a magnetic moment. So this I will apply here by 2m by x cube. Clear? 2m by x cube. This is a magnetic moment is M and magnetic field is B. I will compare with this equation with the electric field produced by a electric dipole along the axial line. What is electric dipole? Electric dipole means two equal and opposite charges separated by a small distance. Normally we are considering a plus q and a minus q charge separated by a 2a distance, and the direction is to be taken from minus q to plus q. So P is a electric dipole moment, that is P is equal to q into 2a. Okay, clear? So electric field at a point along the axial line, that we already know, if the point is like this, that is x distant from the center. Okay, if it is x distant from the center, the electric field formula is 1 by 4 pi epsilon naught 2p divided by x cube. So now you can compare this equation. So in this equation, change the magnetic variable, change the electric variable to magnetic variable, that is 1 by 4 pi epsilon 0 to mu 0, and P is the electric dipole moment, that is changes to magnetic dipole moment. Now you see this. From this, and you change the E by B. So you will get the magnetic field along the axial line of a magnetic dipole. Okay? So from this we can say that the behavior of the magnetic field produced by a magnetic dipole is similar to the electric field produced by a electric dipole. Okay? So you already know, if the point is along the equatorial plane and that is x distant from the center of the electric dipole, the electric field formula is, this is equatorial plane electric field formula is 1 by 4 pi epsilon 0 p by x cube. The similar way we can find out the magnetic field at a point on the plane of the loop. Okay, that means along the plane of the loop is B is equal to, you have to change this electric variable to magnetic variable, that is B is equal to, instead of E, B, 1 by 4 pi epsilon 0, instead of epsilon 0, mu 0. Okay, and instead of B, m by x cube you will get. Clear? M by x cube. Clear? So from this all we can conclude it as two things. One is we can conclude it as the one is circulating current produces magnetic dipole. And the another conclusion is behavior of magnetic field produced by a magnetic dipole. Dipole is similar to electric field produced by electric dipole. Electric field produced by electric dipole. Okay, this is about a circular current loop as a magnetic dipole.
Thank you for watching the video. Please subscribe my channel. If you like this video, please put like